Okay, well, welcome everybody to Scientific Photonics Laser Safety Educational Webinar. Today is August 30th, 2017. My name is Eric Brown, and I'm going to be the host. And we have joining us Mr. Jim Webb with GLS Services in the UK, and he's the software designer, engineer, writer, chief bottle washer of LaserSafe PC. Is that correct, Jim?
Sounds about right. I also sweep the floors.
You sweep the floors? Well, thank goodness somebody does. Hello, Ryan. I see Ryan's piping in on the message board there, so that's nice. It looks like we have some 11 attendees already, so that's nice, and we're just barely getting started here, so that's good. We also have Neil Leon, who's a laser safety officer, who is also he's a new user. He was on the webinar last month, decided to go ahead and give it a try, and we're going to let Neil talk about his experiences with LaserSafe PC here in a few moments. And him and Jim actually got together when Jim was over here in the States from the UK, where he lives in London. He was here for the eclipse and spent a little time with Neil, and I understand they had a great conversation, so hopefully they'll share some of those details with us. We'll also have an open Q&A session where we'll allow you all to bring in your questions about laser safety or the software or what we're going to present today. Primarily, we're going to present how to use the LaserSafe PC software to address your situations and in the laser safety world, the laser safety officer world, if you will. And we're getting more people piping in, so that's good. And more people joining us, so welcome to everyone. Again, my name's Eric Brown with Scientific Photonics, and we are the authorized reseller, I guess, of LaserSafe PC here in the United States and North America. I'm based in Northern California. Also, our thoughts and prayers sincerely go out to all of our friends who are in the Houston and Louisiana and that whole region where Hurricane Harvey is impacting so many lives. Myself and my wife have several really good friends that live over there in Houston. Luckily, they're doing okay. They're quote unquote weathering the storm, so that's good news to us. But hopefully all of you are also with colleagues. There's a lot of great universities over in that region as well, and so hopefully everybody's doing well. And with that, I think we're getting more and more attendees joining in. I'm going to also mention real quickly that my Ethernet connection on my computer seems to be having a bit of a bug, and I haven't been able to resolve it. So every once in a while, I'll drift in and out. And if you notice me suddenly depart and you can't hear me anymore, Jim will jump in and take my place. But Jim's going to be doing the bulk of the speaking, and in fact, I'm going to be turning the screen over to him here very shortly. But before I do that, Jim, and I'm going to send you the invite, but don't click on it yet, because I wanted to just quickly show everybody our company website. So this is the main website for Scientific Photonics, and if you click on the laser safety software, it's going to bring you to this screen, and we have the demo software. So if you haven't already downloaded the demo software, it's not exactly current, but it's within one release of current, Jim, the demo software?
It's about two releases. There's been an awful lot of releases recently. Yeah. And catching up with the demo software is actually a little bit harder than it should be. So many apologies for anybody who's got the demo and it's actually a little bit out of date.
Well, it still gives you a good idea of how the software works, and you don't have to pay for it, and you can test it out. It does limit you on the assistant, which Jim will point out what that is here momentarily. It also only limits you to one wavelength. That'll but otherwise from that, it basically gives you the full experience. And then, of course, if you wish to purchase the software, for the attendees that are here today, it is still on sale. The Great British Pound hasn't brutalized us too much, so we were able to keep the sale price. In fact, I think it dropped a little bit last time I checked. It looked like it dropped a little bit.
$128 last time I looked.
Yeah, so yeah, it looks like that sale price is safe. In fact, we're gonna send out a coupon code for everybody for an extra $100 off. We may be having some issues with the website, so we may just have to invoice people, send them like a PayPal invoice, and they can use their credit card that way. So if the cart feature doesn't work, it should work, but if it doesn't, hopefully we've got the bugs worked out, but if it doesn't, just shoot us back an email and say you want to be invoiced, and we'll invoice it to you via PayPal, and you just pay safely and securely and easily via PayPal using your credit card or however you want to do that. So real quickly, here's kind of the brief page on the laser safety software and such like that, and some of the short introduction videos and webinar videos and things like that. So just wanted to go ahead and do that. And I see, again, we have more people have joined us. So real quickly, briefly recapping before I turn it over to you, Jim.
Okay.
Is welcome again to Scientific Photonics webinar on the laser safety training on the LaserSafe PC software. We'll have a Q&A session. We also have Laser Safety Officer Neil Leon with Johns Hopkins University. He's on, and he's also a new user, purchased the software about a month ago after watching our last webinar, and he's responsible, I think you said, over 250 different lasers, right, and growing, and so you're finding all kinds of great uses for the software. So I'll let you and Jim chat about that momentarily, Neil. Jim, I'm going to go ahead and turn that over to you if you want to go ahead and take control of the screen.
Okay, I will start sharing now by doing this. Do we all see the software?
I do.
I don't know how everybody can put their thumbs up, but if we just have a quick yes from everybody, that would be great on the chat line. I'm hoping everybody can see what I'm seeing.
I can see it. Can you hear me?
Right, yeah. I'm getting...
Jim, can you hear me?
Yep.
Oh, okay.
I can see your screen. Yep, I think we got everybody on board. Good, excellent. Yeah, well, I think we're all happy. Well, at least the number of people I've seen so far seem to be happy. Oh dear, excuse me. My name's Jim Webb. I'm based in London, UK. And as you probably gathered from what Eric was saying, I've been responsible for designing and writing the software. The software goes back quite a lot of years, actually, back to the before 1990, when I had to do an awful lot of calculations. And whenever you go through the standards, there are a lot of tables to go through, a lot of complicated maths, and being a particularly lazy person when it comes to heavy-duty maths, not that I don't understand it, but it's a pain in the backside doing it longhand and stuff like that. So I wrote myself a little bit of simple code to help me work on it, and that was the embryo for LaserSafe PC. Partly because it's not as sufficient just to give yourself an MPE value. You're all familiar with MPE, of course, maximum permissible exposure. You use the tables, you get the MPE. What does it mean? It's a number. You need to know what you're receiving, and then from that create a ratio of what you are receiving to what you should be receiving. And based on that ratio, you get a very rapid indication of if you're in a safe situation or an unsafe situation. And that was the whole background, the whole ethos behind LaserSafe PC, where you put in your parameters, it'll work out the MP given the parameters, and it will tell you, are you running safe, are you not, based on that ratio, which we call, I sort of lovingly call MPE excess. Now, excuse me. Based on that, a gentleman by the name of Brian Tozer got in touch with me and said, would I like to take that software to a much greater extent, because I was only working on the visible at the time. And I said, well, how far do you want me to take it? And he said, full-blown scientific. And that really was the start of LaserSafe PC, which version 1 was, well, you know, as always, a pretty dreadful program. Version 2 started really doing the business, and then we went up to version 3, 4, and 5, and we're onto the Windows part. So now you're going to see, get a quick overview of what the software will do. As you can see the screen, it'll calculate for, oh, the little help thing isn't coming up, never mind. Little icons. You've got options for small point sources, extended sources, fiber optics, LEDs. Now, the old version of IC 60825, which most of this software is based on, back in 2001 included LEDs as a high brightness source, which LEDs at the time were starting to get brighter and brighter, and people started getting concerned about their ability to hurt. So what transpired was we included LEDs in that. The 2007 incarnation of the IEC standard, 60825, didn't have LEDs in it, but we've left it there more for historical reasons and a means of being able to evaluate whether your LEDs could potentially cause a problem or not. Next button is diffused reflections. And hello, Nina. Okay, sorry if I pronounced your name wrong. After that, we got scanning. And then from that, you can get your MPE tables or AEL tables. You got access to all those. Quick overview of all the classes and useful notes for safety officers. Right. Something happening there on the screen. I don't know if anybody saw that. Normally, I would have done single
no need to worry,
point source, but
no need to worry.
Okay, I'm going to start on fiber optics, which is Neil's favorite little thing. In fact, what I'm going to do, I'm going to put some values in. As you notice, you've got your basic input: screen, laser beam, wavelength, exposure to time beam, beam time frame, output power, etc. Now, you've got the option there from these little flyouts. I call these the flycons. You've got repetitively pulsed or single pulse. Okay, I'm going to go repetitively pulsed, and we're going to go energy. And I'm actually going to ask Neil to give me a few values to put in based on some of the work that he's been doing. Can you hear me, Neil?
Yes, I can.
Right, give me a wavelength that you're working on.
Okay. 760.
760, done. Now, when I hit enter, you'll notice underneath here, you've got this this assistant here. Assistant tells you what you need to be putting in and guides you as to what parameters you can put in, why you should be putting them in there, and other helpful things like, for example, the spectrum. It's broken up into the various ultraviolet C, B, A, visible, infrared A, B, and C, etc. Okay? Also, there's a little table here that shows you whether the results can be additive or not. In other words, whether the wavelengths affect each other or not. Okay, so we've added in our wavelength. Notice it tells you in here that it's actually infrared. Okay, now if I hit enter and go into the next field, it now tells me what the time scale is all about, etc. Everything's there to help you. Okay, how long exposure? 10 seconds, 100 seconds?
100 seconds, which is going to the standards.
Okay. Now, you'll notice there's a little flyout there. You've got the options of being able to select all the way nanoseconds, microseconds, milliseconds, or seconds. There's nothing worse than having to put in, say, for sake of argument, 5 nanoseconds, and you've got to put 0.00000000075 or whatever. Real pain in the backside, which is why you've got these little flycons which give you all the magnitudes. You can select them. Milliseconds, if I click on that, it's milliseconds, but we want seconds. Okay? Pulse energy?
120 millijoules.
120 millijoules. Now this, of course, when we actually use that, and we go to millijoules. And funnily enough, down there you've got definitions as well. If I was selecting power, it would also give me the option of dBms. This is for the telecommunications people. Neil pointed out a while ago that there was an omission in the software, that it didn't actually include joules for the fiber optics, because it was basically aimed at the telecommunications people. Well, that quickly got corrected, so we've now got millijoules. Mode field diameter?
Actually, it's single mode, not multi-mode, so we got to go and change the multi-modes. Step index.
Okay, which one? Step index?
Yep.
Done. And NA of what?
.22.
0.22, done. Distance, 0.1 of a meter, 1 meter, what?
0.1.
0.1, right, point blank range, good. Rep rate?
Rep rate is 1 kilohertz.
Okay, we've got the option of either putting 1,000 or being lazy and just going zap there. And pulse width?
5 nano.
There we go, the 5 nanoseconds. So instead of putting 0.00s in, it won't let you put more than 5 digits, 5 or 6 digits in there anyway. It's pointless. Again, as you might have noticed, as we moved along, every single step of the way, Assistant was showing you what on earth you're doing, why you're doing it, and how everything is defined, and everything to help you along. Okay, so we now hit the, well, I can either hit Enter, which will take me to a blank field, which is effectively get the result, or hit the equals button. So there we go, bam. As you've probably noticed, the accessible emission is 1/3 of a million times greater than the MPE, which kind of tells you we got an ouch situation. Very, very dangerous. Okay, but that's not enough. We need other stuff, and this is where these new buttons which have come in there helping us. Calculation details. Hit that. Kaboom. What do we got? As it's a pulse train, the standard tells you have to calculate to, we got another joiner. The standard tells you that we have to make 3 basic comparisons to either a single pulse, a pulse train, or the average MPE. All those are calculated internally, and the most limiting result is then used to give you your MPE excess. And from this, the pulse train MPE is the limiting factor. It tells you there's a class 4 device. It also gives you hazard levels. Again, with the telecommunications people, they have a system called hazard levels, and that's again quite useful for them. For this particular case, we just worried about the class itself. Gives you all useful data, what the power densities, energy densities are, average power, which again is useful to know, accessible emission, what it actually is. These are numbers to help you calculate what the situation is based on the actual values, and if you want to do it by hand, do it via your MPE tables or whatever, these are the values you can use. You've got the apertures, extended NOHD, etc. It also gives you skin accessible emission, which tells you that the skin MPE excess is 86 times the MPE, which means you don't put your hand in front of this fiber either. Nominal hazard distance, extended NOHD, etc., etc. Spot size of that distance, beam divergence, exposure train. Now, does Assistant do anything for us here? Yes, it does. If you click on any one of these fields and you're wondering what on earth it means, you just click on that, and not only does it tell you what it means, it also gives you the math behind it. Peak beam irradiance, definitions, average output power, how that's derived, NOHD for you who really, really like a lot of math, there it is, lots of it. Extended NOHD, same sort of thing, and of course you get the pictures to illustrate what the various areas, what the various elements of that mean. Skin MP excess, etc. Now, so far so good, but it doesn't just stop there. It'll now give you safety eyewear and filters that you need to use to protect your eyes against this level of radiation. Now there's a thing here that I'm actually working, this one is working specifically to the EN standard or the IEC standard. We haven't incorporated the ANSI standard in, but they're very close, so the results are actually quite similar. The ANSI standard will be included quite soon. However, there's a bit of an I wouldn't say an argument, but a bit of a problem with selecting eyewear, because the European and the IEC standards tend to use what originally were called L numbers. Now they've gone to LB numbers, which are based on the ability of the eyewear to withstand the power and optical density. If you want pure optical density for the American standard or the American style usage of safety glasses, you've got the minimum OD that you need to have yourself safe. In this particular case, minimum OD, you round it up to 6. The L number, funnily enough, is RL6. The LB numbers differ for glass and plastic, which is down to the ability of the glasses to be able to handle the power densities. And you can see the plastic is actually slightly different specification to glass because it's more sensitive. RB numbers are to do with visible, so that's irrelevant. And then you've got these other values that give you an indication of what power strikes your glasses. Again, Assistant is there to help you identify what those funny little letters and numbers mean. Okay? Now, if you're not happy with just these results, you can go even deeper into the whole affair. Sorry. Where you get the correction values, C5, again, there's your C5 value. Every single step of the way, there's something to help you with Assistant, okay? Pulse train duration, actual pulse train, and for those who really want to work out, are those eyewear values valid? We've also got in-depth information and all the correction factors to do with the LBs and LB numbers. Like, for example, that's how the glass correction factor is obtained, and the plastic correction factor. I don't involve myself with the actual writing of the standards. I just have to take on board what the standards are saying and incorporate that in the software. Hi, Peter. Right, now then. How much further can we go? We can click onto here and get classification details. Not a big surprise if you click on areas like that. Assistant is back there to help you. But if you want a really in-depth analysis of how that classification was reached, this will tell you how it was done. And it will also tell you where the failures have transpired. So you can tell that that's a class 4 by the fact that it's failed class 1, failed class 2, and there's a failure on class 3B. Therefore, by process of elimination, it has to be a class 4. And now the various conditions, condition 1, condition 3. Okay? We can also go to hazard levels, different set of parameters. That's really for telecommunications people. Okay? I'm going to shut this down now.
Okay, before you shut it down.
Okay, tell me.
Jim,
yeah,
this is one of the things that I find very useful for me is once you have all 4 of these open, you can ask for a file and have it save this information as a text file.
Exactly.
So
if you click, yeah, go on.
Yeah, go up and click File, Save.
Exactly. However, having said that, if you go to here, just with a straight calculation, the calculations are saved in a proprietary format. If I go to Save As, for example, it'll tell you can save it as a LSF file, okay? The LSF file format is a proprietary file format, which if you click on it from your desktop or whatever, it'll automatically open up the software and load that calculation, which is a bit of a nicety. I won't bother saving this. But what is nice is when you go into these areas here, you can do a Save As again. Hello? No, it's not allowing me to do that for some reason. Okay, right, Save As. Now, you have the option of either saving it as a text file or even nicer, as a CSV file. So you can take that as a comma-delimited file and put that in the spreadsheet if you wish to process it a bit further for whatever reasons. So you can save it as a text file, as a reference which you can put into a logbook or whatever it is that you might be dealing with, or alternatively print it out and put it with the appropriate laser that you're dealing with. But those are all the various options that you have on that. And not a big surprise, let's shut that down. Once you're here, you've also got the option of preloading a previous calculation. Okay? And in fact, it just so happens, this happens to be one of the calculations that Neil had sent me a while ago. Okay, I'll shut that down. Now you'll notice the screens keep disappearing every now and then. If Assistant keeps bothering you, you can always hit this little button which knocks Assistant right down to the bottom, so you can now see everything without having to worry about Assistant tracking the bottom of the screen all the time. It can be a bit of a pain in the backside sometimes. There you go. Everything there available right on screen. Excuse me. Now, one of the little niceties of this is I've done the calculation, and if for some reason or another you weren't particularly happy with, or you weren't sure about some of the values on there, particularly the MPEs, you can always go to the MPE or AL table, and we click on that, and there it is. Opens up as a new window, right? Allows you to put the wavelength and the exposure time in there to get your MPE value, or AL. But you'll notice this funny little symbol here as well. It's another little nicety that we put in there, that if you click on that, it'll take the parameters of the previous calculation, plug them in, and lo and behold, there's your result, 760 nanometers at 5 nanoseconds. So you've got all the result, class 1, 2, 3R, 3B ALs, exposure, skin exposure, eye collection aperture, everything you need to know, angle of acceptance, irrelevant because it's not a large source, and the condition measurements, and also the correction factors. Everything you've ever wanted to know from a piece of software. I'm going to shut this window down now that we've shown this lot off. Incidentally, once we go into the MPE calculator, you'll notice that it actually, for the fiber optic, we deal with the IC or EN 60825 2007 standard. The ANSI does exactly the same, I might point out. Here, we've got the option of selecting results for either 60825, the most recent 2014, ANSI standard, CDRH classifications, and 2001 for the LEDs. You've got the options, all those options available on the AL MPE calculation. So you've got tables with historical values in there as well. I'm now going to go here. The moment you click on that, all your screens disappear, apart from the MPE calculator, which will lose that as well. Just to show off some of the other things, we've got the various standards here. Now again, the IC or EN standard has these values. You'll see a class here called 1C, which is for contact purposes, for skin therapy, etc. And the theory is that no radiation should escape. It's a bit of an oddity, but it's in there anyway. But if I were to change standard, which I can do now, kaboom, 1C disappears. And if we go to the CDRH, you get the, well, there you go, the Roman symbols. And if you click on each one of these, it'll give you an in-depth indication of what these mean. That funny little button there gives you a quick overview of what they are. And if I change standard, again, kaboom, kaboom. Okay, it's very, very quick to change standard. I'm going to do a very, very quick retrieve a saved value here. Just show how easy it is to, I did some 1 megahertz test, why not? Boom, we do that. Results straight away. Notice 488 nanometers, that's an approximate color of 488 nanometers. Also notice that symbol there shows that it's a flat top beam. If I was to do the calculation, I've also got the options of either a Gaussian beam or a flat top. So I can change that, flat top, recalculate, and recalculate. Boom, slightly different value at 5 meters. Excuse me. Again, the usual sort of stuff here with these values. I'm going to get rid of assistant again. Boom. Boom. There. Just to show you how potent the standard change is, if I change standard here, everything changes, also changes positions. All the values have changed. Now you've got watts per square centimeter instead of watts per square meter. Your C values now become CA, CB, CC, K lambda, CP, CE. And all the units are correct for the appropriate standard. And if I move on to CDRH, again it changes the come on, there we go. It changes all the numbers again for you. And if you're particularly interested in that, in all the various values from there we go, including K1. Let's bring back assistant. All the values are there for you. K2, KC. Okay? Let's whack this down. How are we doing for time? We're actually doing quite well for time. I think I've shown most of what this thing will do. Incidentally, if you happen to have other open windows with other calculations, all the calculations will change standard if it's appropriate for the standards to change. The other thing is when you're inputting values, I'm going to show off a couple of other features. The moment you change a value, I'll make that 2. That obviously invalidates previous calculations. Obviously it won't affect the MPE calculator because that's a standalone. Okay, we'll close that down. Okay. If I were to delete that, now if I'm entering the values here, let's bring back assistant. That shows you again what you're entering. This is the beam diameter. Okay, so I enter my 2 millimeters. Now if it's a circular beam, don't need to enter it again. And me being lazy, if you hit enter, it'll repeat the previous value. And what's an even nicer nicety as far as I'm concerned anyway, I'll delete that there. Back to 0. Okay, go back to there. You've got the option of either milliradians or degrees. So if I now set that to degrees, go to the next field and hit enter again, it'll give me exactly the same previous value, a degree. Yes, I'm lazy, I know, but I just like these little things just to help make life a lot easier and quicker. And there we have it. Okay. At this point, I'm going to open up the floor to questions if anybody's got some comments to make. Okay, who's unmuted? Hello, is there anybody there?
Hello, I'm here.
Ah, jolly good. Any comments? I believe that was Neil talking.
Yeah, I was going to let other people talk before I said anything.
Okay. If anybody, I don't know if anybody can see their little microphones or whatever, if anybody's muted or not. You're quite free to talk if you've got access to a microphone or make some comments. Okay. For a tunable laser, okay, good question. I've got that. Okay, I'm getting that. All right, I've got the chat things. Right, for a tunable laser, if you remember, for these inputs here, let's alter the wavelength to something else. Remove that. For a tunable laser, you have to decide what wavelengths are significant, what wavelengths aren't significant. For example, if you have any wavelength within the UVA, all the values are additive. In other words, if you know the individual wavelengths, you have to add them all together. Now, the real problem is with if you're tuning a wide range, that's where it becomes a problem. So you have to take the average of the wavelengths that you're dealing with, and hopefully, I say hopefully, and be able to deal with the average power within that range and use that value to calculate what your results may be. So if your average, for the sake of argument, in the ultraviolet happen to be, if you've got, I don't know what wavelengths are you thinking of tuning? I'm on the chat.
While waiting for that, the laser that I was talking about was tunable.
Okay, what sort of wavelength range?
and it went from 690. It went from 690 to 930, and I chose for my calculations my maximum power wavelength.
Okay.
Maximum energy wavelength, to use that as the basis.
Right. Now, this TISAF seems to be going from 500 to 1400 nanometers. Is this continuously tuning, or is it just selectable for a particular wavelength? Because that's really the key issue. If it's a complete broadband, so you're actually emitting from 500 to 1400, you need to know what your peak is. And also the fact is you are covering quite a lot of different wavelengths. So that could be quite a complex calculation. And this is where the various wavelengths have breaks, particularly peak of 700. Okay.
Just so Ryan knows, we have him unmuted. If he does have access to a microphone, he's welcome to talk. Yeah.
Are you coming? Today,
are you
at 5 for his going away thing?
Is that Ryan talking?
It sounds like a lady talking.
I didn't think that was Ryan, but never mind.
This is Ryan right here. Do you hear me?
Hey, Ryan.
Yes, I can hear you. Okay. Is this? Do you select individual wavelengths?
So I knew.
Let me see if I can mute that. That's talking.
Okay. Do you select individual wavelengths, or is it continuously scanning the wavelength range?
Continuously scanning.
Oh boy. Okay, that's a problem because all the various wavelength domains do change, and I'll tell you for why. I'm just looking at the MPE tables here, and the wavelength breaks are 500 to 700 nanometers, 700 to 1050, and 1050 to 1400. So you have to take an approximate peak within each one of those ranges to get your calculations there. It's a bit of a problem when you have a heavily duty tunable thing, particularly in the near infrared, because there are a lot of breaks in the wavelengths. In the near infrared, from say 700 to 2600, you've got 1, 2, 3, 4, 5 different wavelength breaks, and that's where it becomes a bit of a problem. This is where you do have to have the tables at hand and choose your central wavelengths in each one of the ranges to get a feel for what it is. It's not easy to just calculate for one wavelength only.
Okay, that makes sense. Thank you.
Okay. This is one of the unfortunate things for an individual, for a single wavelength or a set of single wavelengths. Not a problem. If you've got a whole broad range that you've got there, you're actually covering 3 domains, which is a bit awkward. Sorry, you're covering 2 ranges. Okay. Any more questions? Anybody would like to field?
Hey, Jim. While people are thinking up their questions, why don't you talk a little bit about what's upcoming, attractions to come in the next big release? And we are going to have another webinar in almost exactly a month from now, the end of October. The date escapes my memory right at this moment, but I know you're working, because you got a suggestion from the last webinar. We had somebody ask during Q&A and they had a great suggestion about laser safety signs. So I know you're really working hard on getting that very soon. We don't have an exact release date yet for it, but we're hoping. But why don't you talk a little bit about?
We're hoping to have a release date by the end of September. Depends, because a lot of testing. Whenever you do something like this, you have to get it right. For lots of reasons, basically making sure that it's a quality product. But the thing about LaserSafe PC is it's a growing product. It's like a living organism. It evolves. Any problems that arise, which they can do, of course, in software. Like, for example, recently we hit a really weird problem, which nobody could have predicted, but it was to do with a conversion of an integer to a double precision value, and it wasn't exactly the value. It was a tiny little bit less than what it should have been, and when a comparison was made with an equal value, it gave the wrong results. which is really frustrating when when computer math goes awry. Digital and decimal really don't mix, but that's another story. These are the weirdness that do happen. But a great suggestion which came up in the last webinar was a lady asked, will it indicate what laser safety signs I ought to put up? And the obvious answer is, well, no, it won't. And I thought, after a little bit of a discussion with Eric and a couple of other people, I thought, okay, we'll release a new version which incorporates, which will show you the laser safety signage appropriate for the laser class which the software has determined, which you feel would be quite useful, particularly for putting on equipment, for putting on doorways, for putting on anything else that you need to know about. So we're now formulating what's the most appropriate way to put it together, what information we need to put on there, because each one of the various standards has its own particular way of dealing with it. The IEC has got its own way of going about it, ANSI has got its own way of going about it, and CDRH have got their own way of going about it. So we have to incorporate all three and make it give the correct and sensible result. There will also be notes to guide people as to what is the appropriate place to put these and what they actually mean and why they should have them.
I think it'd be best to just have a big danger sign with a picture of somebody like, getting fried by the laser. Big scary laser.
That's the classic one. Of course, if you're Mexican, you can also have refried lasers. But anyway, that's another matter.
By the way, you can find Jim in London, United Kingdom. His address is 123. I'm going to be assaulted by the Mexicans way. London, England. Send all your hate mail there, please. Don't send it to me. Remember, Jim is with GLS Services. All right,
also, Jim.
Yes, I'm here.
Also, one thing you didn't mention is the thing with being able to use energy for laser, for fiber optics came out of our webinar a month ago.
True, that did happen. Yes.
This was a semi-release, not a full release grade, which he did to assist me because being in a university environment, the vast majority, I'm getting more and more fiber lasers that aren't used in telecom.
Exactly.
They're used for medical, they're used for interferometry, they're used for a wide variety of things. So knowing the power and not having, people who are non-telecom people, not having to go, okay, what is a dB?
I totally appreciate. In fact, when you had mentioned it, in fact, it occurred to me that yes, it was based on telecoms. So we did a rapid update, and it's now been released. The latest release actually has the Joules option for the fiber optics. All the other ones, of course, you will notice there again. We've got, if I get repetitively pulsed, you've got energy, peak power, or average power options. Loads of power options available to use there. You've also got, for that, angular subtense, size and distance. Everything has got lots of options there. You don't have to be limited to just a particular type of laser. Just about anything you want to do, this software will do for you. And the other thing is, of course, we do go to a lot of exhibitions, and we take on board comments that people make as well, which is, as I say, the ethos behind the software to be growing and living. There's a lot of software out there which is just a piece of software, does what it does, and that's it. It doesn't necessarily adapt to the real world. The real world is changing quite rapidly, particularly when it comes to multi-kilowatt systems. Things are getting scary, and we've actually involved ourselves in a research project to do some damage analysis on materials and be able to use those results for a future release to be able to analyze what happens when heavy-duty laser beams hit different materials. But that's another story. we also involve ourselves to that level. It's not just writing software. Has anybody got any sample calculations they might like to try out? Right, okay, let's have a look at what you're saying, Marianne. Hi, Marianne. I've been a free hazard. Occasionally it will not allow beam diameter or divergence.
Been using, sorry.
Possible. Yeah, hi.
Hi. Been using a free hazard software, and occasionally it'll pop up and say, no, you can't use that divergence or that diameter. It's not possible, and it'll put in a different value.
Not nice.
The math is beyond, or usually I'm in such a hurry. It's like, oh, okay, well, give me the best, closest you'll give me.
That's
but
not
then
good
it doesn't
enough.
make me feel really warm and fuzzy,
This software is designed to make you feel warm and fuzzy, because when you start entering values, there you go. I'll just enter that, clear that, and put that field in there. It tells you what beam divergence is all about. There you go. Ways to calculate it, how you determine it, how it's all done, and it's even got my one of my favorite little diagrams I call the submarine, to show you the effect of beam diameter and beam divergence at different beam diameters and different beam divergences on different axes, and the net result of them not being what you'd expect it to be.
Yeah, I love the pictures. I'm trying to convince my director to let me get this, and he's hesitant.
Just because of that one picture.
Oh, I love the pictures. It speaks 1,000 words.
Well,
yeah.
exactly. Well, and the interesting part actually is the diffuse reflection, which it took a lot of analysis to get the results into that, and we had to model it. And the results that came out of the modeling are quite remarkable. I'm not going to put them on this particular bit, but the images that have come out there are really quite precise as to what as to the way beams propagate when they hit not a diffuse surface, because this is what is called Lambertian optics. There's a particular equation for the way beams go, and by looking at the diagrams, you can see exactly where the beams go. And when it comes to NOHD, it's an eye-opener. It really is.
That would be really neat. I wonder if we could try this blue diode that had given me that error statement.
Please feel free.
All right. Shall I?
Okay, 450 nanometers maybe?
488.
488, okay.
488.
There we go.
One.
Are we talking CW or pulsed?
CW.
Okay. So we go there, we select CW. Okay, how many second exposure? Quarter of a second?
Quarter of a second.
Power output?
Power output, this is a 3B 60 milliwatts.
60 milliwatts, we like this. Okay, that's definitely a 3B.
60, yeah.
If it tells you anything else, you won't believe it. Big diameter?
Yeah, this is it took a while to get this, but they gave me 1 micron by 15 microns.
Ah, okay, you're actually talking about the chip itself. Okay.
Right, yeah, because the specifications, didn't have anything else. They don't give you divergence, but they don't, on the regular spec sheets, they don't give you your,
Okay, so you got 1 micron, is that correct? By
1
15.
micron by 15, yeah.
Notice again, you've got the option of microns or millimeters. And this time we actually have to put in the actual values. So 1 by 15, okay. And the divergences, that's obviously going to be fairly fast on the 1 micron and fairly slow on the 15 microns.
See, that's the thing I think I'm learning. So they had in the parallel 105 millirad.
105, okay, that's okay. And on the slow axis?
The perpendicular. perpendicular, I don't know that fast and slow nomenclature, but on the perpendicular they had 400 millirads.
What? What? Ooh la la. Okay, I've got the wrong axes. In fact. Okay, that would be 450 millirads. And the other one was 105.
Yeah, well, it was 400. Sorry,
400. Okay.
Yeah, 400. Yeah.
Okay. And what sort of distance are we talking about?
Well, for the students, they could be 0.15 meters, 6 inches away. I think.
Okay, let's see where they're at. Actually, okay, they're not that major a problem. It's a problem because it's above the MPE, obviously. But notice the color codes that come up there. I should have mentioned before that we got the color codes on here. Green for total safety, yellow, think about it, orange is in the 3R range, which is a potential hazard, but not necessarily. But you really need to think about it. And if it's in the red, really do think about it. Okay.
But no error message for those dimensions.
Why should there?
So. Well, yes, I'm getting on the other software. See, this is argument to my director for me to be able to get your software. So okay, I guess I'll read more about it. But how you knew that the 400 was the axis 1?
For the simple reason that it's something called the slow axis and the fast axis. The smaller diameter will have a larger divergence.
Okay, all right.
It's a law of physics, I'm afraid.
Okay. I'm up to learning those slowly. Okay. Thank you.
Here's
no
one
problems.
thing to help you get power for yourself to get being allowed to get the software. An associate of mine who's not here today, but who also bought this software as a result of the last webinar, we do this fairly extensively. He's been doing this for nearly 30 years. We've looked at various software here in the United States and evaluated them. He, in fact, has consulted on several of them, but we have not found anything that touches this in terms of what it gives you for the price point. I know that sounds like a lot, and I use it. I use those type of accolades to software very sparingly.
Okay,
there's nothing close to this.
I think he will respond if I can mention other universities that are finding this as the best approach.
Yeah, yeah. What university? U.S.
This is University of Virginia.
Okay. You're stone's throw from me. I'm up in Johns Hopkins University.
Okay. All right. Johns Hopkins and the colleague that you mentioned.
He since he's not here to defend himself, he's actually he's an independent consultant. And without his permission, I would prefer not to reveal his name.
Gotcha. Of course. Thank you all.
No problem. And, you can always have your director watch this webinar and even watch last month's webinar. But especially this one, just have them watch the last 10 minutes or 12 minutes where Jim runs that search for you with your laser, and he can see, how well it works for you.
I think he'd go cross-eyed, actually, because it's not his area of expertise. But so I have to work on the sales from another approach.
Well, he could also hear Neil's testimonial right afterwards as well. And I would say true. Neil, since he oversees over 250 different lasers there at Johns Hopkins and the area, I would say that Neil probably knows what he's talking.
Yes. Thank you all.
Knows what he's talking about. So, and I think Neil's really, I think he kind of expressed it earlier as well, but I think Neil's really been impressed with how responsive Jim has been at getting modifications and even updates to the software where he found I must have went on mute. Sorry guys, my internet connection's a little hinky over here. Hello?
Oh, yeah, I'm still here.
Oh, okay.
Lost you a couple of times.
Yeah, sorry about that. My internet connection here is a little hinky, so it cuts in and out. But I was just saying that Neil may be able to, I know he's kind of mentioned earlier during the webinar how his he had issues with the software, and he brought it up to Jim, and Jim responded and got the modifications made quite quickly. And I don't know if Neil wanted to add any more to that or not. So
no, he went literally had the upgrade that I had requested in days. Yes, it was a straightforward one. Yes, there have been some things, and he's done some upgrades beyond that, but it let me do what I needed to do almost immediately.
Great.
Yeah,
excellent.
And have a very powerful tool that I can do and modify and look at things with having multiple wavelengths very, very fast, and switch them out all on the same system, so I could give a report to port to the end user exactly what they're going to have to deal with as they develop their protocols.
Yeah, it sounds fabulous. I'm going to go ahead and go back on mute. It looks like Ken Barat has a question.
Well, real quickly, since we're getting close to the top of the hour, and we did promise to keep this to an hour, and people probably have to get back from whatever break they're on or get to their next meeting. Real quickly, just wanted to show you our website, scientificphotonics.com. Click on the laser safety software, and you can go here. You can download the demo. If you haven't tried the demo yet, go ahead and download the demo. It's a little bit limited, but it's pretty much what you're going to get. It does limit you to one wavelength, and the assistant doesn't have all of the copyright proprietary information in it that the full version would have, but aside from that, it's pretty much the same thing. The laser safety software is on sale. You can go ahead and click on that link, and that'll bring you to the software page, and you can go ahead and purchase it there. If you are having problems with the add to cart button, go ahead and message me directly, eve.brown@scientificphotonics.com, and I can invoice you directly using PayPal. And with that, I did want to thank everybody for attending. And oops, wrong screen. Why did that? It got me. There we go. That's the one I wanted. Time, and for those of you who have to cut out at 11 o'clock or here in about 2 minutes, thank you again for attending. If you still want to hang out and talk to Jim, maybe even Neil, if Neil can hang out a little bit, please feel free to do so. And with that, I'll just go ahead and leave this screen up. Or if Jim wants to take back the screen to demo some of the software, feel free. I can go ahead and turn the control back over to you, Jim. But I wanted to thank everybody for attending again, and I will be sending out a follow-up link with the recording of this webinar and also a coupon code for an extra $100 off the current sale price. So with that, Jim, do you want me to turn the screen back over to you so you can run some stuff on LaserSafe PC for anybody that has any questions? And Jim must have muted himself or something, because I can't I can't hear Jim if you're talking, Jim. Jim? Well, I can't hear Jim. Neil, are you there?
Yeah, I'm here.
Okay. I think maybe my internet connection kind of faded out on me. I see Jim online, but I can't see or hear him. But thanks again, Neil, for coming, and thanks for sharing your experiences. And I don't know if since you've been using the software here for a short period of time, I'm not sure what happened to Jim, but oh, it looks like looks like Jim may be taking back the screen. No, Jim, I see you took the screen back. Okay, I guess, I don't know. Did we lose? Jim, are you there? Looks like your screen is showing, Jim. Did you mute yourself? Jim. Oh, gosh. Jim. I guess that's it, guys. I can't seem to get Jim back. So thanks again for showing up, and appreciate it. Have a great evening, or great afternoon, great day.